All right, let's dig even further. This is a graph that has a lot of limits implied, but the tricky part is a lot of them look like they're only coming from like one side of the graph. In fact, that's what these things end up being called. You call them one-sided limits. So if you look up here, the biggest piece of terminology that you need to make sure you're comfortable with, and I know you are because I've seen you do this before, is the idea that like the left side of the graph is the negative side of the graph, and the right side of the graph is the positive side of the graph. So, in order to describe what's happening at 3, like there are 3 different things happening at 3, and we need to get comfortable with all of them. To describe what's happening over here, we're going to use limit notation for this graph and be really clear about which direction we're coming from. So, this like information down here in the left side of the graph, you're tempted to say the limit of f of x. And now it is true that x is approaching 3, but it is approaching 3 from the left side of the graph. And so you do a negative up as a superscript, not an exponent, but like in the same place that exponents usually are, to mean from the left. So again, in the same way that last video I was like obsessed with you hearing the terminology over and over again, I'm going to read limits a lot. The limit of f of x as x approaches 3 from the left. I'm going to do it again. The limit of f of x as x approaches 3 from the left. And then like visually that's actually super easy to decode. The limit as we approach 3 from the left is 2. The information on the left side of the graph implies that the value should be 2. It's not. Okay. Well, what about the right side? Like the right side is implying something totally different. The limit of f of x as x approaches 3 from the right. And again, like same idea, since we're talking about the positive side of the graph, the right side, we're going to use a positive superscript, 3 from the right. So, reading this again, the limit of f of x as x approaches 3 from the right is 4. Because the information on this line implies that the point should be right there at that open and empty point. The problem is, it just isn't. And then the last piece of information that is worth gathering is the actual value, f of actual 3 is 5. So we have 3 different areas of the graph. The left side is telling us it should be 2, the right side is telling us it should be 4, and the actual value itself is 5. This is fascinating because that means that like 3 different pieces of the graph can tell us 3 different pieces of information, and up until limits we had no way of like distinguishing the left from the right from the middle. We would have only been able to describe the actual function value, and we would have needed the picture of the graph to tell us this. Now we have an algebraic way of expressing it. Very cool.